to talk about conditional probability. This video already assumes that you have the fundamental knowledge when it comes to the theory of probability. You already have experience working with the joint probabilities, what is the difference between independent events and dependent events. So if you already know these concepts, this video will be way more easier, and you will be the exact target audience that I'm trying to address in my video. But nevertheless, I will try to go over those concepts briefly and give you a deep dive of what is really happening here. So what is a conditional probability? Before diving into that, let's talk about a probability that is not conditional. And how do we do that? If it's not conditional, then we are talking about an independent event. Yes, let's say we are rolling a dice twice, and we're asking the question, what is the probability that both of the time the results are 2? The result is 2. What it will be just, again, we're looking for a joint probability. Probability that A and B occurring. A and B occurs. Okay. So why they have to be true at the same time? Because in our first try it should be 2, and also in our second try it should be 2. So they should be 2. When I say at the same time, it doesn't mean like simultaneously, but what it means that if the event A doesn't occur, then the B does not make sense, right? So that's why we're saying probability of A and B. They're happening together. So what is the probability of A occurring in the first try? It's nothing but 1/6, because the possible number of positive outcomes is 1, which is 2. The possible number of all outcomes is just 6. And what is the probability that in the second try, we will have 2 again? It's the same. And why are we multiplying it? Because these are independent events. When we say independent, it means that in our second try, its result is unaffected by the first one, because these are independent trials. The second trial is not in any way related to the first one. That's why it's called independent. So P and B, P, A, and B occurring at the same time is nothing but probability A multiplied by probability B, simply for independent events. And let's look at the dependent events. Let's say this example will be a bit more complicated. Let's say we are looking for a joint probability. Okay, P, A, and B again. And we are saying the dice has 6 faces, and we're saying what is the probability that when we throw this dice, the result is odd and prime number at the same time. Now, before that, I want to ask you this question. If we know that the number is prime, does it affect the outcome of that probability that is odd? That is the question. You can pause the video. So the question is, we know that the number is prime. Does it affect the probability of being odd? This is the question. You can pause the video, but I will go further. The answer is yes. It turns out that actually all of the prime numbers are odd numbers except for 2. So in this case, what we are trying to calculate is that, for example, the probability of P and A and B occurring simultaneously is that, for example, let's say A is odd and it's prime. So we're asking this question. We are calculating simply this. P A, given that B occurred, multiplied by PB. Because the outcome of the event A is dependent on the B, we have to look its conditional probability multiplied by the probability of B occur, because we cannot just write there PA. If we write PA, then it means that we are looking at the scenarios where P even didn't occur. Then we also need to take that into account. The outcomes where A happened and B didn't happen. But we are not interested in that outcome. We're only interested in the outcome that A and B occurred. So that's why we're looking at the probability that PA A occurred given that B occurred multiplied by the probability of B occurred. And it will give you the joint probability. A